Okay, so I'm Amr Ramadan. I'm one of the group mentor sessions here, and this is week three of um, the Python Essentials course. Today we're going to talk about object-oriented programming and list comprehensive. So, what is object-oriented programming, or why do we need it? I'm going to start with like an example, or actually, let me just give you a brief intro about it. So, OOP helps you structure your code by grouping related data together and behaviors into objects. What does that mean? You basically create classes which are blueprints of what do you want to build, and then you start using those classes and create objects out of it. And why do we need all that? We need it because when the code gets bigger and more complex, it's easier to manage the code that way. It's more user intuitive and it helps with the usability of the code after that. Uh, right now, the example that I'm gonna give is just to explain how is that. And there's like four pillars, first of all. There's four pillars of OOP, which is basically encapsulation, inheritance, abstraction, and polymorphism. We're going to talk about inheritance in this class, but you should definitely know all the four pillars. Four pillars are like that's the four main things that you use with OOP. Okay, so the example I have here, just to explain why do we need OOP and why should we use it, is let's say we want to create three employees, like we want to create records of three employees with the details in it. So what I did here, based on our like current knowledge in the class, is created a employee one, employee two, and employee three. And I started adding the details that I want to add, which is basically the name, age, and title. Um, Same here for employee two, Jack 28 DevOps. And then employee three here, I just added the name and the title. And uh, if you wanna like print the name of employee one, you do something like this, right? Print employee one and then the index of zero, which would print um, John, right? So, but you need to know that the name is stored at the first index, and you need to assume that all the employees that you created are following the same pattern. But if you forgot, for example, like I intentionally did that, I forgot to add the age over here, it's gonna mess up your data, right? So a better way and a more structured way to do this is using the class, right? So how do you define a class or how do you create a class? In Python, it's pretty straightforward. You just type the word class and next you just put the name of the class. In our case here, we just want to create a class for employees, right? So we can just call it employee. Uh, and by convention in Python, we follow the camel case. So the you always start with the first letter as capitalized. And if your class consists of multiple words, like say employee one, for example, or employee internal, so you would continue with the camel case like that. This is usually the convention in Python. Okay, cool. So we now have our class. What do we need in our class? Well, we need some variables, we need some attributes to define. Uh, so first thing is there's something called the init function, which is basically your base. or the your base method or your base function that has the attributes or the values or the variables that you're going to use throughout your class, right? So you define it by saying define, and then you emit, and then auto completes whatever you want to. And it's always in any method in inside the class, the first parameter is always going to be self. This is how the syntax work in Python, and this is how it should be followed. After that, the parameters that you add is also feel free to stop me if you have any questions or you want to ask about anything. And if I'm going too fast, let me know. Uh, yeah, so what parameters or what variables do I want to add? So basically what I want to add here is uh, what I want to add here is what the name, which is the name of the employee. I also want to add the age and title. This is what I have. You can add more variables if you want, but this is basically the examples that I have here. I'm just trying to implement using the conventional programming or the methods or the data structures that we learned and just try to implement that in a class. And pass basically is just a placeholder till you write the code that you want to write. So we are gonna write the code now. And so now you need to initialize those variables. When you call the class, you're gonna pass those variables to the class, right? And you want to have separate classes, sorry, separate objects and different objects like employee one, employee two, employee three. Those are three separate employees, right? So how we do that is basically we call self.name and then we pass in the value name and then self.age, we pass in age, same goes for title. Okay, so now we have our class ready. I don't want to complicate it or actually let me zoom out. Okay. I don't want to add a lot of things, so I'm just gonna show you how we can call the class or how can we instantiate the class and create an object out of it. So this is the blueprint that we have. And oh, see, good catch. Title is title. Um, okay, so now what we want to do is basically start calling that class and creating objects and instantiating that class, right? So how do we do that? Uh we would first, let's say, create a variable and then we call the class, right? So we would say something like employee, which is the name of the class, and then we pass in the variables needed, and the variables here are name, age, title, right? Which is basically what I have here. So I'm just gonna copy those here. So what I have right now is I created I created an object of that class and it has those three variables. What I can do right next is uh, create another object with another employee for another employee, and it's going to have the same syntax. It's just the values are going to differ. The idea here is that if you fail to pass any of those variables, Python is going to throw an error. I just want to show that, for example, like what I did with employee three here. Let's say I remove age. When you try and run this, it's going to throw an error, right? Because it's missing one required argument, which is In this case, it says title because I only passed in the first two, so it assumed that the first two is name and age. If we want to create a second employee, E2, say employee, then we pass in those three over here. Okay, so if we wanna, so now we created employee one, created employee two with these variables. If we try and print, let's say we want to see what are the details of those objects, right? If we try to print it right now, what we would get is basically the memory address of that, which is something not really, which is not really what probably what we want. But I'm just gonna show that and then show you how we would fix that. So if we print E1, it's gonna show us the memory address. E2 is gonna show us the memory address where the object is being stored at, right? So employee object, then this is the memory address. But what if I want to print details about that class and what it does or what it stores? I would have to create another method. Uh, this time gonna it's one of the internal methods or one of the like built-in methods that comes with classes in Python. It's basically the string method. And this I'm just gonna pass in self, and this is basically gonna print details about the class, right? So I'm gonna return, then f string, and then let's say we want to return name, and then say self. So the name, which is self.name, and then age, which is self age, and then title, which is uh, self.title. Okay, so right now, because I added the string function, it's going to print the description of that class. So if I print E1 and E2, it's going to print it that way with those provided variables. So now we have name, John, age 26, title developer, Jack, age 28, title DevOps. Um, yes, the main usage of string is basically to return uh, the string. There are
So
other
like don't do any like you know how when you did it for the class and you initialized it, you can't do that in a string function and you only use it when you need to print or return. That's it.
yes, that is correct.
Thank you.
And there's other, let me try and pull them up. Uh, Give me a second. Yeah, so they are called Dunder methods because they begin and end with like two underscores. And these are built in. Let me try and look up all the list. Mm, 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 mm. Oh yeah, I found the link. So these are the Dunder methods. We call it like magic methods or Dunder methods, which is basically built in. We used here. Oh, I was. Yeah, so this is the string one that we just used. There's like a lot of them, right? And this is the init. So it's useful to know a couple of them that you're gonna use throughout coding in general. Cool. Let's jump back to the let's jump back to the IDE. Uh, Give me a second. Okay, cool. So now we know how to create a class. We know how to uh, add the variables or use the init function, and also we use the string function. We know how to instantiate a class or like create an object and then pass in the parameters needed. Next thing is with classes, you can create more methods, right? You can create your custom methods. Let's say you want to create a function that I don't know, maybe checks for how many years that employee has been working with the company. So you could have a function that maybe called years, for example, and you pass in self and maybe the name of the employee also, or actually you don't need to pass. Oh, yeah, the name of the employee, and maybe we want to do some iteration if this is hard coding it for so if name, if self, the name equals John. So let's say we know that John has been with the company for I don't know 5 years. We're just gonna return if and then name and then say self dot name, which is John has been with the company for 5 years. Then you can do else if for the other name, Jack. This is probably not the best way, but this is just to show you what, because like you would have to hard code every single employee name, which is definitely not the best way. But this is just a very simple example to show how to build different methods inside a class and try to understand how it works. So you do self.name equals what do we have? Jack. Uh, or we can just do else since we only have two employees here. Else, and then we just return. Maybe that one has been with the company for 2 years. And if you want to call that function, let's say with John, you'd say E1, which is employee one dot years, and then you want to pass in. Actually, you don't need to. We don't need the parameter name here since it's already initialized in the function. Um, and we can do print e1.years. And yeah, if we print that, it should, um, since we did it for E1, which is John, actually, let me just comment that out so that's more clear. So we print that with John, it's gonna say, it's checking if the name is John, which is John, because E1 is defined with the main John, and it returned that string, which is John has been with the company for 5 years. We did that for E2. It's gonna return Jack has been with the company for 2 years. And you can obviously make more functions and more functions, and maybe evaluation or something, eval, and it shows the evaluation or the yearly evaluation of the employee based on the name or the title or the job description or something like that. So the idea here is that you have all that encapsulated here in that class. So that blueprint is your map here, and you can expand it as you want. And this is definitely a better way than having just the normal data structures like an array or dictionary or and without understanding what it does. Because you can imagine if this is like 1,000 lines of code or 2,000 lines of code, and you try to use that variable, or someone else is using your code and you're collaborating with other people, do no one is gonna remember that the first index is the name and the second index is the like zero index is the name, the one index is the age, and the two index is the title, right? So this is like the main usage I would say for classes, just to have more structured coding, or like OOP in general, more structured and more organized way of coding. Next, I think, any questions so far?
No.
Awesome. Okay. Um, Something else I want to talk about is basically inheritance. Let's say I want to build another class that uses the same class that I have before. Let me just comment out that and start from scratch with a different class. So I always like to start simple, so I'm just going to create a class called parent, and I'm just going to define color maybe or something. It's just a variable here, and then say black, right? What if I want to create another class and use the variable that I have in parent in that other class? I would create another class which I'm going to call child, which is a child of the parent that we just created, right? And in order to inherit, in Python, you would want to pass the class name between parentheses here. So basically, what I'm doing here is just pass. What I'm doing here is that I created class, it's called parent. It has that variable. And then I'm creating another class, which is the child of that parent. And how do I know it's a child of that parent? I mean, obviously the name is child, but it's inheriting or by using those parentheses and passing in the class name. over here. So that means that any variable over here or any function or anything, let's say the class employee that we had, uh, all those functions that we had over here, we would be able to access them in that class. And why is that like important, or why do we do that? Just think in like inheritance helps with like you don't have to type the same exact things again if you're just gonna use them as is. So it saves you time and it makes your code less like less not super long, because if you have to repeat every single thing that you're using, then you'll have like a big chunk of code that is unneeded. Um, that is one example of like inheritance. Something else that like let's say mm, if we have maybe like parent and then we have speaks, for example, which is a language. Let's say a parent speaks a language, so their kids are supposed to speak the same language and maybe they learned a different language, right? So how would we implement that in coding? It's say the language is English and the child and we want to use that uh, variable which is speaks in our child uh, class. So what we do, I'm gonna define an in function because we don't have an init function over here. And it actually already inherit like VS Code here auto completes everything. So I just hit tab and it knew that I wanted to inherit from that class because I already passed it over here. So what it did for me was super, which basically means that you're inheriting from the main class. And if I want to add like a variable to or another value to the speaks array, what I want to do is I'm going to say self dot speaks dot append. It's an array and I want to add a value to it. Let's say another language that the kid or the child would know is, I don't know, French maybe. That means that the array speaks is now has English and French inside it. So that's basically inheritance in a very nutshell, right? This is just an overview or like how it would work. There's more complex implementations and there's more complex usage for these kind of classes or these kind of variables or methods or usages are different. Next I have, what did I have? Okay. So this is like a very brief intro about OOP and very brief like how to use it, usage. Next thing that I wanted to discuss is list comprehension, which is unrelated to classes or OOP in general, but it's a different topic. Um, so the normal way that we know how to define a list, let's say we create an array, an empty array. Let's say I want to add the numbers from 1 to 10 inside that array. So the normal way I would do that is basically do a for loop, something like for I in range 10, which is basically from 0 to 9. What do I want to do? I want to array do I want to append to that array. So I'm going to do array dot append, and I want to append I. And let's print array. So that array should have values from 0 to 9. If we print that, we see it has values from 0 to 9, right? What is list comprehension, or how would be useful in this scenario? Um, it would be useful if we did. It's basically the Pythonic way of doing it, right? Python is very optimized, and we did use how many lines right now? We use 3 lines to implement this, right? Another way to do it would be list comprehension, right? Which is, let's say, array2, and we're gonna do create the array, right? But instead, we're just gonna pass in the for loop inside it, right? So for I'm just gonna say for I in range 10. Oh, sorry. So what am I doing here is basically what I did in 3 lines over here. I just did it in 1 line over here. So right now, if I run this, I should have 2 outputs. They're both exactly the same. This is the first one, second one, right? Uh, the first and second one are exactly the same. It's just a different way of implementation, right? A different way of implementation, meaning that this is a more condensed way, and this is more a verbose way to implement.
Well, I more so meant why is there like two eyes, like I for I in range 10? I know it's normally like for I in range 10. Why is there two eyes? What does the second one do?
Okay, so for I in range 10 means that you have your variable I here, which is how do you define a for loop, right? The other I is what do you want to append, or what do you want to add to that array. So you see the square brackets here?
Okay, that makes sense.
Yeah, so that's the second I, but this is the counter of the loop itself, which is the same definition as here, but this is what you're adding. So basically, this is the line over here.
That makes sense. Thank you.
Well, no problem. Um, yeah, so as I was just saying, it's the same exact implementation, just Pythonic way of doing it, one-liner, condensing it into 1 line and understanding how it works. You can expand on this on like different applications or different implementations for it. And let me try and pull in another example that had yeah, okay. So another example is, let's say if I want to add only if uh yeah, let's say only add one element, and I want to check if that element is 2, for example. I only want to add 2 to my array. So the array should only contain one element, and that element is the number 2, right? To do that inside the for loop. And of course, you can do it outside the for loop and just append 2 to the array. But this is just, again, this is a very simple example of a simple implementation, and just to show it how it works. So I would do something if I is equals 2, you would want to append that. So right now, if I print that, it's just going to contain one element, which is 2, right? And if I want to do that in list comprehension, I would add an if condition at the end, which is if I equals to. So that means it's only going to append, it's the same exact condition that we have here. So that array2 is should have the same value, which is 2, right? I'm just expanding on how we can use array list comprehension or array comprehension. That's another way you can add it. It's just a simple example, but you can expand that. Like if you add like, I don't know, even numbers or odd numbers or like prime numbers or something like that. So that's why you need the loop. That would actually make more sense than the example over here, because if you just want to add 2, you could just do array, but append over here and add 2, which would be the best way to do it. Yeah, I think that's all what I had for today, actually. Any questions or anything you want to ask about?
I have a question. It's kind of not like exactly related to that, but if I have the syntax, how come I can't make anything? Like I can't build anything.
Wait, what do you mean by you cannot build? Like, you know
Like
the Python syntax, but you're not able to build.
anything, yeah. Like I don't know, like it just won't connect. I don't know how, like at all. Do you know what that is?
Um, Wait, okay, so you know Python, you know the syntax, but you're not able to write code, right? That's what you're saying?
I could write, like if you said, okay, make a function, or how you went over the class today, make a class, but I couldn't like put it together to make
Okay,
any.
so are you solving any like lead code questions or any data structure?
Only like the binary search, super easy ones.
Okay, that's a good start. So the idea of those questions is that they tell you a story, or like they give you a description, right? Of what do you wanna, what you're trying to implement. The easy questions would give you an idea of how to get started. But I understand what you're saying is that you know the syntax, I don't know how to add things up or like actually build something, right? Building something
Mhm.
starts with baby steps. It's like how we started with the employee here, right? We just started with we wanted to implement this, then we started adding functions, another function to it, and so on and so forth, right? Lead code questions could help with uh, like when you're given a problem and you want to solve it in a programmatically or in a Python way. If you're using Python, you want to solve it in a programmatic or automatic. Yeah, lead code questions would help with that. Uh,
Okay, so probably just do more of those, get more range in versus a binary search, and eventually I'll be able to think of something I want to build and then be able to build it. Because I'm like, I don't understand how people are doing that.
yeah, but you also the binary search example that you just gave is a good example, right? Do you know the implementation of it? Like, do you know that why do we use binary search? Because um, if you know like why we're using it, you would understand that you're actually implementing something which is you're searching faster, right? If you're given a list of like 1, 2, 3, 4, 5, 6, right? Binary search would find the number that you want to look for. Let's say, for example, 2 in this case, faster than any other algorithm. And an application for that is, uh, let me think of something. Um, Yeah, an application, a very good application is a phone book. You know that old phone books or something, or like any normal book that is arranged in order, right? Uh, Alphabetically or in order. Is if you want to search for something, like as a human would do, someone would start from the start and start looking for from page 1 to page 100, right? But if you know how to approve, if you know that it's sorted, then you know that binary search would be a good approach here because you can start from the middle and then see if it's bigger or smaller than the what you're looking for or not. I hope that makes sense.
Hmm. And then adjust the high and the lows from there and continue again.
Yep,
But I couldn't build anything with that. That it's still like a piece, but I don't know how people are making the full thing.
true, true. It's one piece of the whole thing, right? Let's say you want to build let's say you want to build a website or an application that does. You're not going to build something that uses binary search only, but you're going to build something that utilizes binary search in the building process, if that makes sense. Like that class that we had here, this function, you're not building the entire class for this function. This is just one uh, utilization of the class, right? But you can add other functions to it, and then you have a big whole thing. So what you're learning right now is just basically the small methods or the small functions that you can add together to build something bigger. And how would you do that? Just to back to your main question is you either start with a project, like the lead code questions will help you understand the small stuff, right? And small problems, you start solving them by yourself. But to integrate all that together and have one big thing, I would definitely recommend working on a project. Uh, like I don't know if you do you have actually projects here at the end of the class or
So let me ask you this, right? So what you went over today, I feel like I said, I've seen and done the classes. I feel like this is very good. But then the assignments are like 10 times harder than like the materials. Did no? Am I the only person?
I think I've heard that before that the assignments are pretty harder than what you're, but I haven't actually looked at the assignments before, so I'm not really sure what kind of assignments are you all getting. Um, but there's like one-to-one sessions that you can attend, right? Or something like that.
Yeah, for sure. For sure. It's just like I said, like I feel like this makes sense, and then I get to the assignments and I'm like stuck. But this was a really great lesson. You're a great teacher. I'll be tuning in on Saturdays. Thank you.
Awesome. Thank you. Have a good day. Bye.
Bye.